This is the regression slope from the size only model. Remember, I'm going to show you the summaries. I'm going to just do this. Here's the summary of the size only model, right? It only has size. The difference was 6.9 on average between big and small, ignoring the fluffy, scruffy distinction. Here's that line. This is a line that passes through the mean of the small dogs and the mean of the big dogs. This is like if I said, I gave you a pen and I said you get to draw one line. You want to get as close to these points as possible. When we control or adjust for fur type, we add that into the model. Then we get to draw two lines. But it's like we're holding both pens at the same time, right? The lines are constrained to be parallel. We don't get to draw two totally different lines. We can just draw them spaced apart, but in the exact same direction. So that's what we would get. This is
why, Sarah.
Yeah.
Why can't we think of it as far as like the average between what the two slopes would be? Like, is there a fatal flaw in thinking about it like that?
No, that interpretation is exactly right. If you think of it as a weighted average,
Okay.
based on the sample sizes for the two groups, then the interpretation is right. And if you didn't understand what Ricky asked, I think you will in a second when I plot the slopes from the interaction model. She's thinking
okay.
ahead.
Am I? Okay.
This is controlling for fur type, but with no interaction. And then we get to draw the same line twice, kind of at two different positions. And you can see it's not perfect, right? We're kind of missing the middle of this cluster. And, we're a little too high in this cluster and we're a little too low in this cluster down here. And then here is the lines for the interaction model, the most complex model. And so remember, the black line is overall size effect with no information about fur. The dotted lines are the slope of size from the model that adjusts for fur, and then the solid red and blue lines are the simple slopes of size from the model that allows size to interact with fur. And those are the ones that come closest, they don't just come closest, they pass directly through the means of all four of these subcategories. That's an illustration of the fact that the difference between big and small was like, 16 up here in the blue dots, the fluffy category. And we're gonna have to add 14 to that negative 16 if we want to look at the red category, the scruffy ones. It's gonna flatten that line out a bunch. Those slopes are different. It's the difference between big and small for fluffy is different from the difference between big and small for scruffy. It's a difference in differences. And the dotted lines, there is no difference in differences. The difference has to be equal. It's a simpler model that has a constraint that the difference has to be equal, but we're just allowing the lines to be at different positions. So it's like if you took the solid red line and the solid blue line and you tilted them towards each other until they had exactly the same slope. For the sake of simplicity, you're not going to allow them to be different. So you're kind of coming up with the average slope between these two groups. Sure, it's actually steeper in the blue group than the red group, but the dotted lines give you an average of what the solid blue and red lines would give you, which is what Ricky was asking. Is it okay to think of it as just the average slope of size within each of these two groups? And it is the average slope of size within each of these two groups. The only reason I try to be careful about saying that is because it's not just the exactly halfway in between those slopes necessarily. If you had a lot more blue dots than red dots, then it would be closer to the blue slope. It's the weighted average across the groups, weighted by their sample sizes.
And like you said before, because size and fur are correlated and they kind of go hand in hand with this outcome variable a little bit, this is why looking at those main effects might be especially important, because you're obviously getting a picture of that relationship between size and Borks that's quite different than if you were to completely ignore the fur, right? Like that's
Yeah.
why you do something like that, because that's a huge difference in the conclusion you would make.
Yeah, I mean, it's a difference. Well, it's a difference in the information you have. It's a difference in what size appears to be doing
Mhm.
in your
Right.
theory, right? But the conclusions are totally consistent, right? It is true that big dogs borked more on average in this data set. And it's also true that big fluffy dogs borked less and big scruffy dogs borked less. So it's like, if you don't know whether any given dog is scruffy or fluffy, I just told you it's big, then you would guess that it was going to bork more. But if I
Right.
told you that it was fluffy or scruffy, then you would change your guess to think that it would bork less than an equivalent small dog, and you would be justified. It's about having more information and then making a better prediction based on it.